Welcome back to class. Today we're going to engage some of the arguments that have made that climate science has got it wrong, that either the Earth isn't warming on average or that humans are not contributing to that warming. There are a lot of these arguments and they've been around for a long time. But to sum up, there is no compelling explanation about why the planet has been warming and our climate has been changing that has been validated by scientific research published in peer-reviewed scientific journals other than the addition of greenhouse gases to Earth's atmosphere. There are many things that may be contributing to warming right now, but the main driver of these changes is the addition of greenhouse gases. But let's take a few minutes now to look at some of the arguments that have been made. I don't think we need to go into all of them, but I just want to give you a sense of the arguments that have been made and are likely going to continue to be made despite scientific evidence to the contrary. Here's a publication, Forbes magazine. This is an excerpt from an op-ed piece that reads, "The bottom line is that the temperature records are not consistent with the theory that human greenhouse gas emissions are the primary cause of global warming. Those records do not show temperatures rising in conjunction with such ever-rising emissions as the globe increasingly industrializes." And this is from March of 2012. So this is asserting that there is no association between greenhouse gases and the warming trend we've observed. So let's look at the data. So this is data from the National Climatic Data Center, NOAA, and what it shows is the temperature anomaly. And remember, the temperature anomaly is just the difference between an average temperature, in this case between 1951 and 1980, and the temperature of that given year in this case. So this is the temperature vector going from 1880 to the present. The blue bars are years in which the temperature was lower than that average, and the red bars are years that the temperature was above that average. And you can see that the global temperature, in this case Fahrenheit, went from about 57 at its lowest around 1900 to about 58. And that's about the 1.5 degree of Fahrenheit warming that we have talked about before. Now, overlying that graph is the CO2 concentration, and that is the black line. As you can see, the black line here goes from about 280 parts per million by volume to where we are today, actually about 395 parts per million. So this is the recent temperature record, and it seems to suggest that, in fact, there is at least a correlation between carbon dioxide concentrations and temperature, in contrary to what this article in Forbes is saying. But this is only 120 or so years of data. So we have temperature records and carbon dioxide records going back hundreds of thousands of years. As we've talked about before, the carbon dioxide records can be obtained by ice cores that have trapped bubbles of air from the Earth's atmosphere, and the deeper down those ice cores the bubbles are, the older they are. And this graph shows data from 4 different Antarctic ice cores in shades of blue and the temperature in red. And what you can see over time is that there is a fairly tight correlation between the red lines and the blue lines. And that persists over periods of hundreds of thousands of years. What's astounding is that the data indicate that there is a very tight correlation between carbon dioxide and temperature over hundreds of thousands of years, and yet people continue to write that there isn't an association between greenhouse gases and temperature. In that same piece in Forbes, another statement is made. It states that instead, the temperature records show an up and down pattern that follows the pattern of natural influences on global temperatures, such as cyclical sunspots and solar flares, and cycles of ocean churning from warmer to colder temperatures and back, such as the Pacific Decadal Oscillation. So we know from previous evidence presented in the class that looked at the various radiative forcings that are influencing the Earth climate, which include solar activity and the temperatures of the oceans, that if you look at the sum of those radiative forcings, the sum of those makes it quite clear that things like solar activity, while relevant to the Earth's temperature, are not driving the current warming. But what about these natural cycles that are referenced here, like Pacific Decadal Oscillation? So let's start with asking, what is the Pacific Decadal Oscillation? And this is a graph that's oftentimes cited by people who our questioning of climate science. It refers to periods where the Pacific decadal oscillation is cool and periods in which it's warm, and asserts that over several decades, in some cases 4 or maybe 6 decades, there's a natural cycle, this Pacific decadal oscillation, that explains the variability, the up and down in the Earth's average temperature. If that's the claim, let's try and understand what the Pacific decadal oscillation is and how it may affect the Earth's temperature. This is a map that shows what the Pacific decadal oscillation does to ocean temperatures. The Pacific decadal oscillation has effects upon ocean temperatures in the North Pacific Ocean, very near Antarctica. And in its cool phase, it makes the waters off the coast of Alaska and down along the western coast of the United States cooler, as is pictured here. And in its warm phase, it makes those same waters warmer. So the Pacific decadal oscillation occurs every decade to perhaps every 4 to 6 decades, shifting between its warm and cool phases. And this graph shows what's known as Pacific decadal oscillation index over time, and you can see that there are periods of time where the waters in the North Pacific are warm and periods when they're cold, and these are the warm and cool phases. You can see that there's variability going from warm to cold, but the question is, does this variability, which is considered a reflection of normal Earth systems that are natural and don't have anything to do with greenhouse gases, do these changes, these natural changes, affect the overall warming trend of the planet? So let's look at this graph. So here's the Pacific decadal oscillation index, as we've discussed, on the bottom here in blue. And this is the variability we discussed, going from warm phases up here to cool phases down here and back again to warm phases. And this is the global temperature anomaly, just as we've discussed before. So the temperature anomaly here on the right axis goes from about minus 0.3, this is in degrees Celsius, up to about 0.4 or so. Again, the 0.7 degrees Celsius warming we've seen since 1900, which is about the 1.3 to 1.4 degrees Fahrenheit. So you can see that the Pacific decadal oscillation goes up and down during this period, but it has no net trend, which is to say it has no contribution to the overall warming trend we've observed. It goes up and down, as it does and as it likely has for a very long time, but that does not in any way influence the overall warming trend that we're seeing. So again, the argument that the Pacific decadal oscillation can explain the increase in warming and temperature doesn't hold any water. Next, we're going to turn to a piece from the Wall Street Journal. This was published in March 2012, and the title of this editorial is "Global Warming Models Are Wrong Again." And in this article, the author asserts that there has been no change in temperatures over the past decade. The author refers to data from the University of Alabama, and that is freely available on the web, and claims that this data makes clear the case that warming has not happened over the past decade. So let's take a look at what this data shows us. So let's take a look at the data that this author refers to. If you follow the link from the editorial, you will come to a website with the data that is described, and it is pictured here. And what I want you to do is look closely at this graph and think about how it differs from graphs, similar graphs that you've seen presented in this class, including the one I presented earlier in this lecture from NOAA, as well as the one from prior lectures from NASA that shows a temperature anomaly since in the last 100 years. And think about what it is that makes this data presentation different. And as a part of the assignment for this unit of the class, we're going to ask you to report on what those differences are, with the goal of having you understand why this presentation of the data is in fact misleading. Here's our next argument. This one comes from the Wall Street Journal from January of 2012, and it reads, "The fact is that carbon dioxide is not a pollutant. Carbon dioxide is a colorless and odorless gas exhaled at high concentrations by each of us, and a key component of the biosphere's life cycle. Plants do so much better with more carbon dioxide that greenhouse operators often increase the carbon dioxide concentrations by factors of 3 or 4 to get better growth. The second paragraph here is undoubtedly true, that carbon dioxide is a stimulant for many plants. But in later lectures in this class, we're going to talk about why carbon dioxide itself, on balance, is in fact not at all good for plant growth and agriculture. But the first part of this suggests that carbon dioxide is just a naturally occurring gas that we breathe out and plants breathe in, and is a normal part of the Earth's geophysical processes. And that is entirely true, except what's going on now is something very different. And to understand that, we need to understand a little something about the Earth's carbon cycle. The Earth's carbon cycle is just the series of processes that occur as carbon moves through the life and physical components of Earth. So photosynthesis captures carbon dioxide out of the atmosphere. Carbon can be stored in soil. Carbon is also, of course, stored in the world's oceans, and most importantly, in the deep ocean. There are huge carbon stores. So it's true that as we breathe out carbon, plants and soils breathe it in. But what's different about what's going now is that we are tapping into carbon sources that are not a part of this cycle. So we're tapping into the fossil pool of carbon. And those fossil fuels have essentially not been a part of the carbon cycle on Earth for millions and millions of years. So in effect, we're adding to the overall total amount of carbon dioxide in the world's carbon cycle. And it turns out that as we release the carbon in the fossil pool, the sinks in which that carbon can live outside of that pool are not growing. So in fact, we're losing forests, which is a major sink, and we're disrupting land in ways that release carbon dioxide from the soils. So just as we're taking this reservoir and putting it up into the atmosphere, by burning it as fossil fuels, the sinks we have to absorb that carbon dioxide are decreasing. So the idea that carbon dioxide is a part of a natural cycle is entirely true, but the important point here is that the carbon dioxide that we're adding to the Earth's atmosphere by burning it in the form of fossil fuels is adding to the overall amount of carbon circulating in the carbon cycle. So it really is a very different thing. Here's our next argument. So this is another editorial published in Forbes, which is entitled "An Unsettling Week for Global Warming's Settled Science." And it says, people who claim that the science is settled on global warming have to be pretty unsettled by the science news in the last week. Settled science, of course, means that we are inevitably headed toward a disastrous warming of surface temperatures as forecast by some computer models, and we therefore need an international carbon tax or cap-and-trade system pronto. The prompt for this editorial was a new piece of research, which the author references here. He writes, "Now it appears that cloud tops are lowering, a totally unforeseen cooling feedback on carbon dioxide-induced warming." Writing in Geophysical Research Letters, University of Auckland's Roger Davies and Matthew Malloy conclude this could be a, quote, significant measure of a negative cloud feedback to global warming. The average global cloud height is linked to the average global temperature generally. The higher the average cloud height, the higher the average surface temperature, and vice versa. The tie-in is related to the height in the atmosphere from which clouds radiate infrared radiation to space. The higher up they are, the cooler they are, and they dissipate less radiation, which means the surface stays warmer. This argument, like others we've already discussed, holds a kernel of truth. It is entirely true that clouds do affect the overall temperature of the planet, and the lower they are, the more likely they are to be cooling. And if we turn our attention to the paper itself, the paper itself does in fact state that their observations have found that the overall level of clouds has decreased. And as a result of that, they should have a cooling effect upon the planet. I've excerpted here from the article in Geophysical Research Letters, and the authors mentioned that they've looked at 10 years of satellite data that shows a global cloud height trend of about -44 plus or minus 22 meters. And what's interesting is that they also note, and the editorialist also, to his credit, makes mention of this, that the difference between the first and last year of the decade, not directly affected by the La Nina event, is -31 plus or minus 11 meters. Now, we haven't yet talked about El Nino and La Nina, and we will later on in the course, but suffice to say, El Nino events have to do with the circulation of ocean waters along the equator in the Pacific. And during La Nina events, it is expected that cloud heights will lower, so that if you're observing a period in which La Nina is occurring, you would expect clouds to be lower anyway. But the assertion of the authors is that even on the tail ends of the La Nina event, the cloud height was lower. So they conclude at the end of their paper that if this decrease in the cloud height continues, that in fact it will have a net global cooling effect. Now, the authors are very cautious. They say they only have 10 years of data, which is a very small amount of time, especially since when we talk about climate as opposed to weather, we're talking about temperatures on the order of decades, not on the order of months or years. So usually when climate scientists talk about climatic change, they're talking about changes at least on the order of a decade and usually many decades. So to make a claim about overall climate trends based upon a decade of data is very difficult. But suffice to say, their point remains that if this trend continues, cooling will occur. The issue here is the context in which the editorialist looks at this data. So if it is in fact true that cloud heights have been lowered and that as a result of that they have had a cooling effect upon the planet, which may be entirely true, it does not account for the fact that the past decade in which this data was observed is the single warmest decade on record. And we've seen this graph before that ranks the hottest years to the coolest years going back to the 19th century. And the red bars represent the years between 2000 and 2010. And you'll see almost all of them are in the top 10 warmest years. So even if there is a cooling effect from these clouds, it is not adequate to reverse the effects of the warming driven by greenhouse gases. Now the next question, of course, is could this potentially lead to more cooling in the future, that if the clouds continued to lower, would they in fact get low enough so that the effects of greenhouse gases would be reversed, and that in fact planetary warming would slow down or perhaps cease as a result of this. This is certainly not what climate models have told us, and it is a very big assumption to make based upon very limited data, given the bulk of data that suggests the contrary. So suffice to say, this editorialist has put a great amount of credence into a very new idea that, even if true, given the last 10 years of data, has not been adequate to explain the overall warming trend observed. So the last point that this editorial makes that I want to address is the idea that climate science is unsettled. And the evidence there suggests that that is a false claim. So there have been several research studies trying to understand what the scientific community believes about the state of climate science. So the last statement I want to evaluate from the editorial we've been discussing is the claim that the science isn't settled. And there's been significant research to understand whether scientists actually have settled upon the fact that greenhouse gases are the major contributing force to the warming we're having. This is a paper that was published in 2009, which asked a group of about 3,000 scientists, do you think that human activity is a significant contributing factor in changing mean global temperatures? About 90% of the respondents were American, and about 6% were Canadian, and there were small representations from many other countries. Most of them had doctoral degrees. They came from a variety of disciplines. Interestingly, 5% of the respondents specifically identified as so-called climate scientists, but most people identified based upon the doctoral degree that they'd obtained. And about 8.5% of the respondents claimed that 50% or more of their publications over the last 5 years were climate science publications. And this is what they found. So the general public in the United States, 58% would agree with the statement, do you think human activity is a significant contributing factor in changing mean global temperatures? This is as of 2008 that survey was done. But among climatologists who are active publishers in climate science, that percentage is 97.4%. And what's interesting is that even among scientists who are not necessarily climate scientists, the percentages are much, much higher than the general public, in fact, well over 70%. So this suggests that scientists who really are focused on the issue of climate change overwhelmingly believe that human activity is a contributing factor in changing mean global temperatures. Here's another piece of research on this subject. This is from Naomi Oreskes, who's at the University of California, San Diego, and she published this paper in 2004. And she investigated whether or not there was agreement among scientists on the issue of consensus. And the consensus statement she referred to is from the IPCC, and it reads, human activities are modifying the concentration of atmospheric constituents that absorb or scatter radiant energy, and that most of the observed warming over the last 50 years is likely to have been due to the increase in greenhouse gas concentrations. She looked at 928 peer-reviewed papers which had as a keyword global climate change. So she searched through the scientific literature using global climate change as a search term. And there were 928 papers. Now it's important to understand what peer-reviewed scientific literature is. The process of peer review means that when someone does a scientific research study and submits it to a journal, that other people in the field evaluate that paper to see if it is worthy of publication. This is quite different from publications that may occur in non-scientific journals, where people may write opinion pieces or pieces that don't get reviewed by experts before publication. So in this case, all of these papers have been reviewed by experts in the field. And of the 928 publications, 75% either explicitly or implicitly agreed with the consensus statement that I read before. And 25% made no mention of it at all, but that's not because they necessarily disagreed. It's because these were papers that looked at methods or methods used in climate science, or were paleoclimate analyses, so meaning that they were looking at the Earth's distant past, the Earth's climate in the distant past, and so it wasn't relevant to make a comment about climate change occurring today. And the sum total of this paper is that of the 928 peer-reviewed papers that addressed global climate change published between 1993 and 2003, not a single paper published in a peer-reviewed journal was in disagreement with the consensus statement. If there's any more powerful statement about scientific consensus about the fact that humans are driving climate change in the scientific community, I don't know what it is. This is another paper published in 2010 in the Proceedings of the National Academy of Sciences, and it did a similar analysis looking at scientific publications related to climate change, and divided people into two groups in the review. There were those scientists who were quote-unquote convinced by the evidence and those who were unconvinced by the evidence. And scientists were grouped into these two groups based upon public statements they had made, petitions they had signed, books they had written that either said, yes, we agree with the idea that the planet's climate is warming and that humans are driving that warming, or they had done similar activities but come to the opposite conclusion. And what these authors try to do is to understand how much science these individuals were in fact doing, and that's what's pictured here. So on the bottom of this graph are the number of publications for each number of publications that have been published and the number of researchers that fell into each of those bins. And the blue lines represent those who are convinced by the evidence, and the green lines represent those who are unconvinced by the evidence. And you'll see that especially over about 200 publications, almost all of the researchers are people who are convinced by the evidence. And what this is suggesting is that scientists who have spent more time and have greater expertise in thinking and working on climate change are much more likely to be convinced that, in fact, humans are driving the warming that we are observing, and that those who tend to doubt that humans are a part of climate change tend to be less published and less well regarded in the climate science community. So those are some statements about scientific consensus on the issue of whether human activities are leading to climate change. But there are other consensus statements and positions as well. 27 scientific organizations, all listed here, signed a statement that said most of the global warming in recent decades can be attributed to human activities. This is a joint statement from National Academies of Sciences, 19 academies of sciences from around the world. And in this statement, the authors, the heads of these academies, wrote that responding to climate change requires both mitigation and adaptation to achieve a transition to a low-carbon society and our global sustainability objectives. There are yet other statements. This one is from 14 academies of medicine, including the academies in the United States, the United Kingdom, and Australia, among many others. And in this letter to The Lancet, these authors stated that climate change is the biggest global health threat of the 21st century. And the question is, why? And that's the question we're going to turn to next, as we start to explore how these changes to the Earth's climate matter to our health. I look forward to seeing you then.